Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, that is a pumping lemma, guys. So to be clear, this particular topic might be a bit funny based on the definitions, guys. Okay, yes. So basically the main reason why we use pumping lemma is to prove a non-regular language to be non-regular. So that is the original definition for pumping lemma, guys. Okay, so pumping lemma is used to prove that some of the languages is a non-regular. So some language is a non-regular. So basically what we give input only non-regular languages, and we are going to say that they are non-regular. So that is what we are going to conclude. Got it? Yes, I do agree that this topic is a bit funny because I even feel in that way. And to be clear, this topic will help you a lot in solving some questions, guys. Okay, yes. So please concentrate. Okay, so assume that the given question is prove that the language a power m b power n is non-regular. Okay, so now what we do is, so please concentrate for some time, guys. You will get 100% clarity on this particular topic. Okay, so now the given question is a power m b power n, and they are saying m equal to n, right? Yes. Okay, so and they are clear about this. Okay, yes. So now they want this, right? So let us write some language examples, right? So AB, AABB, AAABBB, and so on, right? Yes. So among these all, what shall we take an example, guys? So let us take a traditional case first of all, right? Yes. Okay. So let us assume in this way. So first we will select one item from this, guys. So let us assume we selected a power k, b power k. Okay, so once we have selected this, what we do is we break this item into three different pieces, guys. Okay, so you can break it into multiple ways, but I am going to break it in some standard way. Okay, so what I do here is, so let us break this a power k into two pieces. So let us make one a constant here, and let us take a power k. If I remove one, it becomes a k minus 1, and let us write a b power k here. Okay, so what we call this as, so we assume this as a u, this as a v power I, and this as a w. So you observed, right? Yes. So please concentrate, guys. So this is a u, this is a v, and this is w. Okay, so when it comes to u and w, they are constants, guys. But when it comes to v, so here I wantedly wrote that power I, right? So v is a, so v power 100 is what, guys? A power 100. So basically here I indicates it could be increased to any power as per my requirement. So now if I increase that power by 100, so indirectly my end result will be what, guys? So if I multiply, it becomes a k minus 1 into a power 100 into b power k. So if I continuously multiply it, so it becomes a power k plus 99 b power k. So can k equal to k plus 99? The answer is no. Hence, I can conclude that this language is not regular. Got it? Yes. So this is the approach with respect to pumping lemma, guys. So the given question, we break it into three pieces, and the middle piece can be repeated infinite times. So your goal is to make it non-regular. So that is the reason why we are going to make it a large number. So like 2 also you can take. So even if you take 2, you will get a k plus 1 is equals to k. So that's also not possible, right? Yes. So now you understood, right? So what exactly we are doing with respect to this pumping lemma? Yes. Okay, so to be clear, most of you think that you understood, but please take a problem and solve it, guys. Please Google a question and you try solving it. Okay, yes. So only if you solve it, you can remember this in the examination, right? Yes. Okay, so the steps are, suppose that we need to prove that language L is not regular. Assume that L is regular. So basically at the initial stages, we will think that it is regular. Okay, we already know that it is non-regular, but we think that it is regular. Okay, then L must satisfy pumping lemma property. Okay. Okay, so after that what we do, we take a particular z that belongs to language. So basically we will take a particular string which belongs to z, and the z length should be less than or equal to n. Okay, so then you are going to compare this particular condition. So basically you can skip this particular condition, guys. That will not affect that much. So we are going to break it into three parts, u, v, and I. Okay, so they say that the length of this z should be less than or equal to n. Okay, so basically I think we can follow that, right? So u and v should be less than or equal to length. Okay, so in our example, what will be the thing, guys? If we try to follow this condition, So let us try, because these type of things can be asked in the examination, right? Yes. So what will be the length here? So here it should be, okay, so mod z is a less than or equal to n. So that is a nothing but, okay, so they are saying at least one item should be there in this. Okay, that's what they are saying. Okay, that's the reason why I told we can skip it, right? Yes. Okay, so indirectly what they are trying to say is, so if this length is a 2k, at that time this length should be lesser than or equal to 2k, right? And here we should have at least one item. That's what they are saying. Okay, yes. Okay, so now I understood. So basically u, v, w, so v can be increased up to I and u and w. Okay, so if there exists at least one variable for which I such that u, v of I, w does not belong to L, then L does not satisfy pumping lemma property. Hence we can conclude that that language is not regular. Got it? Yes. So if you want to represent in the diagrammatical approach, it will look in this way. So u will be here, w will be here, and we can rotate as many times as it wants. Got it? Yes. So you can take as many examples as you want, guys. But you understood, right, the exact concept which I am trying to say? Yes. So if you want a small example, you can take this as an example. Here, the value of m should be less than or equal to n. Okay. So here we have broke it in this way. So assume that the middle part has been taken 1000 times. So at that time, automatically this will be greater than n, right? Yes. So you can prove that it is wrong. So it's not it is not a regular language. Got it? Yes. So to be clear, why are we learning this regular language or not here, guys? So to be clear, if a particular language is a regular language, we can construct a finite automata or a deterministic finite automata for it. As these languages are not regular, we cannot construct this finite automata for them. So that is the reason why in the next lecture, we are going to start the next topic, that is a context-free language, or to be clear, we are going to discuss about push-down automata, guys. So that can follow these kind of things. So if you want to equate a power m b power n, which is not possible in finite automata, it is possible using push down automata, guys. Okay, so that is what we'll be learning in the next lecture. I think most probably in the next lecture itself I will be taking an example on this particular push down automata. Okay, yes. So now I hope everyone got a clear idea about the first whole part, right? I think almost 3 to 4 topics have been covered here. So we are done with this regular expressions with automata, context free grammar. Okay, so now we are moving on to context free grammar with push down automata. So this is what we'll be learning here, and we are done with regular grammar, right? Yes. Okay, and we are done with this pumping lemma also. Yes. Okay, so in the next lecture, let us start the concept with respect to push down automata, guys. Okay, so it will take around 3 to 4 lectures. That's it. Okay, yes. So in the next lecture, let us start the concept with respect to push down automata, that is a context free grammar or context free language. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.